Welcome back, everybody, to your day 5 of your descriptive statistics unit, part 2. All right, for today, we have a pretty big goal for today. Given a set of bivariate data, and a line of best fit, you will be able to calculate the residual values, plot residuals, and use residual plot to determine if the data has a linear correlation. Okay, so to do that, let's first talk about, well, what is a residual? A residual, on a scatter plot, a residual is the difference between the original and the predicted value from the line of best fit. Residual equals actual Y value minus the predicted Y value. All right, so that's the equation. Now this is what it looks like. So here's our actual data. Here's the line of best fit. So the residual is how far away it is. So again, here's your actual, here's your line of best fit. Your residual is the distance away from the line of best fit that it really is. So let's go ahead, let's take a look at how to calculate our residuals. So our first example, we're given 5 points. Part A says find the equation of the line of best fit. So here's my line of best fit. They already drew it for me. Line of best fit. So let's figure out what is the equation of this line. So y equals mx plus b. So m is your slope. So if I look at this line, it's going up 1 over 1, up 1 over 1. So my slope is going to be 1x, but I really don't have to put that. So I'm just going to write x. The b is my y-intercept, which is 0. So plus 0. Now use the equation of the line of best fit to fill in the table of values. Use the residual equation to fill in the last column. So the first we have our x and our actual y value. So what we're going to do here is we're going to take our points and we're going to put them down here. This is our actual data. So actual data. All right, so let's go ahead and plug that in. So my actual data, I have 1, 1. 2, 3, 3, 2, 4 and 4.5, and 5, 5. Now, my predicted value, that comes from the line of best fit. So I'm going to take my calculator, go to the y equals, type in x equals 0, and now I'm going to go to my table of values. So my predicted y's are the y values on my line of best fit. So that's going to be 1, 1. For x equals 2, my y is 2. For x equals 3, my y is 3, 4, and 5. So now to calculate the residuals, what we're going to do is we take the actual y value minus the predicted y value. So 1 minus 1 is 0. 3 minus 2 is 1. 2 minus 3 is negative 1. 4.5 minus 4 is 0.5, and 5 minus 5 is 0. So here are my residuals. Now let's take a look at what those values mean. So if I look here, a residual is positive. That means, well, let's take a look at a positive value. So here's a positive value, 2, 3. If I look at 2, 3, the residual is positive, but look at the point. It's above the line of best fit. So a residual is positive. That means it is above the line of best fit. Okay, if a residual is negative, that means, well, let's take a look. We only have one negative residual, and that's the point for the 0.32. So let's look at that 0.32. Now, if I look at this piece of data, well, it's below the line of best fit. So a negative residual means that the data is below the line of best fit. And last, if a residual is 0, that means, well, let's take a look. That's the 0.11 and 5.5. Now, if I look 1, 1, and 5, 5, well, those pieces of data are on the line of best fit. So if a residual is 0, that means data is on the line of best fit. Okay, so now that we know how to calculate a residual, let's go ahead and take a look at what it means to plot a residual. So a residual plot. A residual plot shows if a line is a good fit for the data. If the residual plot shows a random scatter of points, then it indicates the linear relationship is good. So random scatter is good. Random scatter is good. If the residuals are not random, then it indicates that the data is not linear. All right, this is what a residual plot looks like. We have our y's. Now your x-axis is actually the line of best fit. So what we're doing is we're taking this line of best fit, like we had in our first example, and we're turning it sideways so that way it becomes our new x-axis. So this is our line of best fit. So if I look carefully, my line of best fit, if I look carefully at my residual plots, well, this piece of data is below the line of best fit. This piece of data is above. This piece of data is on the line of best fit. Below, above, and on. Below, above, and on. Above, below. So if I take a look here at these plots of the residuals, I see that they are scattered. They're above, they're below, they're everywhere. This means a line is a good predictor. And it's a good predictor because the residuals are scattered. Now, if I take a look at this middle line, or this middle graph, again, this is the line of best fit. Now, if I look carefully at my residuals are above, above, on, below, 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 on, above, above. So if I take a look here, are my residuals scattered? No, they're following a pattern. So that means a line is not. So this line of best fit is not a good predictor for the data because the residuals follow a pattern. They're not scattered. That means a line is not good. And if I take a look at the last one, again, remember the x-axis is your line of best fit. If you look at your residuals, once again, they are not scattered. So a line is not a good predictor because the residuals, okay, follow a pattern. You can say they are not scattered. Okay, so that is what a residual plot shows us. If a line of best fit is a good fit for the data. So let's take a look at how we can compare scatter plots and residual plots. So if I take a look at my first scatter plot, so here's the scatter plot. Let's go ahead. Let's say we had to draw a line of best fit. So my line of best fit would look something like this. Now let's take a look. Is a line a good fit for this data? Well, just looking at it, I would say probably not. A line is not a good fit. All right, if I look at the residual plot, remember residual, how far away it is from the line of best fit. So if I take a look, this point is above, this is my line of best fit. So this point is a little bit above. These 2 points are a little bit above. We're going further and further. These are getting further and further and further away, so it's going to go up. Okay, over here, it's coming back. It's getting closer, and now it's going way below my line of best fit. So I see it follows a pattern which is not good. So a line is not a good fit. Now, if I take a look at my second scatter plot, if I had to draw a line of best fit, I would probably put it somewhere around here. So now, I can tell, does this data fit the pattern of a line? No. So a line is not a good fit. Let's see what the residual would look like. Remember, the x-axis is your line of best fit. Okay, so if I take a look, these points are above my line of best fit, so they would be above. Then these points are below, and they're pretty close, but then as it goes on, it gets further and further away. And then it comes back up, and there we go. So this, again, it's following a pattern. So a line is not a good fit. Okay, let's take a look at our very last scatter plot. Okay, so if I take a look here, if I were to draw a line of best fit, does the data look like it's following a linear pattern? Yes. So a line is a good fit. If I take a look, we have points that are above, points that are below, points that are above, points that are below, points that are above and below and above and below. So these are kind of randomly all over. So if I take a look, my residuals are scattered above and below. That means my line is a good fit. Okay, so now that we know how to explain and use a residual, let's actually take a set of data and complete a residual plot. So if we take a look here, we have a set of data. We have shoe length and height, and then we have the predicted height. Remember, the predicted height is from your line of best fit. All right, so if I take a look here, these were already calculated. Here's my line of best fit. I have two more values that I have to actually figure out. So my predicted height, y equals 3.66. All right, I have my predicted height, so I'm going to have to put in this x value. So I'm going to type that in. So 12.6 and then plus 25.25. So I'm going to let the calculator do the work there. So we're going to quit out of here. So 3.66 times 12.6 plus 25.25. We hit enter, and my y is equal to 71 and I'm going to go to the nearest tenth, so 4, 71.4. Now to get to this next one, I'm going to have to type in an x value of 11.8. So y equals 3.66 times, and now I'm going to put in my x value, 11.8 plus 25.25. And now I'm going to type that in, 3.66, 11.8 plus 25.25, and we get 68.4. Okay, so now I have my predicted heights. Now I can complete my residuals. Remember, the residual is the actual minus the predicted. So 74 minus 71.4 is 2.6. 65 minus 68.4, negative 3.4. So you're going to be subtracting these. All right, and we only have 3 left to do. So 69 minus 69.9 is going to be a negative 0.9. 72 minus 71.4 is going to give me a positive 0.6. 71 minus 68.4 is going to give me a 2.6. Okay, so now that I have my residuals, I can go ahead and plot a residual plot. So a residual plot is where we take the x's and the residuals, and we're going to put them together as a matching set of points. So my first point is going to be 12.6, comma, 2.6. Okay, so you can go ahead and write out all of your points. Okay, now that we have all of our points, we're going to go ahead and plot. So 12.6 and 2.6. So I go over to 12.6, and then I go up to 2.6, and I plot, it would be right here. 11.8, 3.4. So go ahead now and plot all of your. So now that we have all of our points, we have to decide, is a line a good fit? Well, I said yes. A line is a good fit because the residuals are scattered and do not follow a pattern. All right. Nice job, everybody.